Elasticity of demand. What changes the demand for a product? Some answers may be price, quality, our needs, and those will also change. Some products that we need and some that we don't necessarily need but want are called luxury items. Some of our needs are food, clothes, housing, gas, maybe. Gas is, we very much need gas. If we drive a car is a want or a luxury. You could ride a bicycle. You don't necessarily have to have a cell phone. You don't have to live in a mansion. You do need some housing though. And honestly, you don't even need the bathroom. You could go out in the yard. Can you think of others? Elasticity of demand, E, is the way to measure sensitivity of demand to changes in price. And this is our equation. We took the four-level fraction here, the change in quantity, divided by the change in price, percent of change in quantity and percent of change in price. And then we took our numerator fraction and multiplied it by the reciprocal of the denominator fraction, and then put the P and Q together and the change in P and the change in Q together. And the change in Q over change in P is equal to the derivative equation of the demand equation, the derivative of the demand equation. So this is Q prime of P. The equation for E helps us to determine if a dollar increase in price affects the demand, or if a 1% increase in price will affect demand. So we use absolute value signs around the elasticity of demand equation, so E will always be positive. For small changes, change in price, we have the change in Q over Q is equal to negative E times the change in price over P. The relationship between elasticity and revenue. If E is less than 1, the demand is inelastic and revenue is increased by raising the price. That means we're going to buy it if the price goes up. When E is greater than 1, the demand is elastic and revenue is increased by lowering the price. That means we don't have to buy it, so we're not going to buy it if the price is too high. If E is equal to 1, then this exists at the critical points of the revenue function. What does elastic mean? If an item is elastic, then we really do not need it and can live without it. So retailers will lower the price to encourage you to buy the item. What does inelastic mean? If an item is inelastic, we need it, and if the price is raised, we're going to still buy it. If E is greater than 1, a 1% increase in price will cause the demand to drop by more than 1%. Then we say that the demand is elastic. If the value elasticity is between 0 and 1, a 1% increase in price will cause the demand to drop by less than 1%. Then we say the demand is inelastic. The larger elasticity causes a larger percent of change in demand for the given percent of change in price. In number 1 on page 211, if the elasticity is 0.5, what is the effect of the quantity demanded if there is a 3% price increase? So we use the equation, the change in quantity over Q is equal to negative E times the change in price over P. These are percentages. So we have our values, we plug them in, we get negative 1.5%. This means that there will be a 1.5% decrease in demand. 3% decrease, we will have a 1.5% increase in demand. There's a table on page 211, table 4.5, and it gives the elasticity of many items. One is the demand for potatoes is E is equal to 0.27. What does this tell us about the effect of the price increase on demand for potatoes? Well, 0.27 is between 0 and 1, so the demand is inelastic, meaning a change in price will not change the demand too much. Potatoes are a staple food item, and people will continue to buy them, but they want to stretch their food dollar, but potato is a good staple product. Number 10, here is a demand function. Find the elasticity of demand when P is 50. If the price rises by 2%, calculate the corresponding percentage change in demand. So we have our formula here. We have the price equation. So we're going to rewrite the equation so that Q is equal to something so that we can get the derivative. And we see we have 1p over negative 10 minus 90 over negative 10, so Q is 1 over negative 10p plus 9, and the derivative of the Q function is negative 1 over 10. So we plug that into the formula and let's see what our elasticity is. This is the change in quantity given change in price. To use the formula, we need to find the Q given P is equal to 50. So Q of 50 is equal to 50 minus 90, which is negative 40, over negative 10, which is 4. Elasticity, we have 50 is the price, 4 is the quantity, times negative 1 over 10. That gives us negative 5 over 4. Take the absolute value, and we have 1.25. If the price increases 2%, we take that 1.25 times the 2%, and we have 2.5%. Now, what does that mean? The change in demand will increase 2.5%. This means that the demand will fall by 2.5% given this 2% increase in price because this value is negative. Number 13, we have quantity Q is equal to 5,000 minus 10p squared. How much revenue will there be if 4,960 pounds are sold? Okay, revenue, remember, is price times quantity. Revenue of P is P times 5,000 minus 10p squared. Revenue of P would be $9,920. Let's take the derivative of that, set that equal to 0. And we get P, the price, is going to be $12.91. We only use the positive value when talking about money, so the only critical point is $12.91 for maximum revenue. And here is your critical value. What are the slopes doing on the left side of it? What are they doing on the right side? When you plug in 0 to the derivative equation, I plugged in 0 here, and I got a positive value. 5,000 minus 30 times 0 is 0, and we get 5,000, so that's a positive value. If I plug in 15 here, then this value is greater than 5,000, so that gives me a negative value. So the revenue is maximized at $12.91 per pound of yams. So what is the Q at price of $12.91? Well, it's 3,333 pounds and a third. So if you plug that value in, you get the revenue is $43,033.16. And then we determine elasticity. And elasticity, when we plug all these values in, we get 1. So we should have expected to be 1 because we used the critical point, and the critical point was when the price was $12.91.